This is problem 2.7 on page 52. You're basically looking at this eye bolt, and it has two forces on it, concurrent forces, and you are to calculate the resultant force. Concurrent forces are easiest, the resultant of concurrent force systems are easily found by using the method of components. What I like to do is just generate a little table, and in this case you have your 80 Newton force, and you also have the 100 Newton force. As far as the 80 Newton force is concerned, it acts at an angle of 0 degrees. So you can break that into components. The x component would be 80 cosine of 0, so that would be 80, and the y component would be 80 sine of 0, and so that would be 0. As far as the 100 Newton force goes, it's acting at an angle of 136 degrees off of the 0 degrees. So you could use your sine and cosine function again. When you use the cosine function, you'll come up with 71.93. That's simply 100 cosine of 136 degrees. When you say 100 sine of 136 degrees, you come up with 69.46. What you then do is you sum the x's up. When you do that, you'll come up with plus 8.07 newtons. Summing the y's up, you come up with 69.46 newtons. Again, since you have the sum of the x's and the sum of the y's, you can simply find your resultant using the Pythagorean theorem as such. When you calculate that out, you'll find out that the resultant is approximately 69.9 newtons. So you have an x component of 8.07, you have a y component of 69.46, so your resultant, like we said, is 69.9. If you want to calculate that angle there, you can simply use trig. You can say the angle, if you want to call it theta, is equal to the inverse tangent of y over x, and in this case that should come up to about 83 point, a little less than 0.4 degrees.